Everyone can see my screen, right?
Yes, sir.
One second. All right. So basically, we have completed logical operators, if I'm not wrong. And we need to bitwise operators. As I told you that we will discuss this later in deep learning. Assignment operators. Again, this is another bitwise operator, and this one also bitwise right shift and bitwise right left shift. We will discuss the remaining assignment operators. X equal to, let's take 7. Basically, we are assigning a value 7 to the variable x. So it's assignment operator. So whenever we want to assign a value, so you need to use single equal to. If you use double equal to, it's going to be a comparison operators. Comparison operator. Right? So x plus, let's take 2. Here is basically the shortcut notation for x equal to x plus, what is the value here? 2, right? So we need to mention 2. So this is the full form of this one. Again, this is an assignment operator. Here x is basically, this x is basically 7 plus 2 equal 9. So it's nothing but adding the value 2 and into the x and assigning again back to x. Right? That is how we got 9. Same way, let's take minus. We have minus equal, right? So again, the shortcut notation for this one, x equal to x minus 2. Here the new x is basically 9. So it is 9 minus 2. Now what is 9 minus 2? 7, right? So we get 7. Same way, multiplication, division, and other operators. X asterisk equal to 2. Basically, it's a this is the full form of x asterisk equal to 2. So what is x here? The new x, x7. So 7 multiplied by 2. It not be just 2. So you can take any value. I have taken example here, that's all. So don't assume that we have to take only 2. 7 to 14. So x is 14. Same way we have division. Right? And this is x equal to x slash 2. So this is the full form of this one. And what is x here? So 14. So 14 by 2 to 7's 14, right? So the quotient part of it is not the remainder. The modulo is the remainder. X is 7. A division always return decimal value, float value. So that's the reason you can see 0.0 at the end. Same way we have modulo. Modulo basically gives the remainder part. New x is basically 7.0. I will assign it back to 7. Okay. Now it is 7. Reset it. 7 by 2, 2, 3, 6. Remainder is 1, right? So we have to get 1. Yeah, 1. So skip this one and move to the decimal power of. Reset this to 7. Just 1. 1 to the power anything is 1 only. So I reset it to 7. And x equal to s to the power 2. So basically this is the full form of this one. Shortcut notation to this one. The 7 to the power 2, right? Which is nothing but 7 square, which is 9, nothing but 49. So 49. So that is how assignment operators works. So any questions on assignment operators? All right, the next one is special operators. So we're going to discuss uh, built-in data structures like lists in detail and dictionaries, sets, and tuples. I have, I mean to say, so we will take an example of a list here, even though I haven't started explaining list, but we need a list or some object here to explain is and is not. So basically, a list is nothing but usually variable will have only one value, right? Or two. Let's consider two here. So I have assigned value two here, and sorry, the x is two. Whereas if you want to store multiple values, let's say 1, 2, 3, 4, 5, list is the right built-in data structure. So we have other alternatives too. We'll see that later. So I need an object, so I have taken a list here. If you check type of it, it will return list. So whenever you want to check a data type, you can use type. For example, y equal to 5, right? To check type, it is integer. Anyway, the point here is that I need three objects. So we have x here. Same way I'm going to take another one, but the same set of values. And I need z also. So, but instead of creating 1, 2, 3, 4, 5, we already have here. So what I do is, so I will assign y to z. In memory, the way it stores is x equal to 1, 2, 3, 4, 5. The same way y will have 1, 2, 3, 4, 5. Z also should have 1, 2, 3, 4, 5 because we copied it, right? Y. But what happens here is that as we have assigned the object directly, it refers to this object. This is nothing but point by difference. So whenever we make modifications to y, it will affect z. And whenever we make modifications to z, it will affect y too. Let's see an example. So here I have taken z equal to y. Let's take z plus equal to 3. I want to add each value with 3. So probably yes, int object is not right out. All right. Yeah. So I made a mistake. Looks like this plus is basically not working, right? Uh, this works. All right. Basically, it changes Z. Let me reset this back to Z equal to Y. And it got concatenated. So okay. So basically, whenever we multiply with 3, it's replicated 3 times. 1, 2, and 3, right? So now what I do is let me check y because we have copied y to z. Even y got changed because these z and y refer to the same object. Any modification to z obviously will affect to this. Any modification to y, it affects it because it directly changes this object. Of course, x will not have any changes because x is completely isolated and it is a separate object altogether. So if it if this is the case that if you want to check whether a particular object is referred by, is point by reference or point by value, is the operator you can use. For example, x is y, false. It is not point by reference. What about y is z? It is point by reference. What about z is y? Obviously, it doesn't matter which direction it is. It's y to z, z to y, it is point by reference. What about z is x. Again, it's not point reference. So x is complete isolated. So it doesn't matter whether it is y or z. When you use is, it always get false because it is separate object altogether. So is operator will help you to check whether two objects are point by reference or point by value. Of course, is not is complete opposite. So if we get false, it will become not of false, which is nothing but true. You can see that true, right? Here we got is, right? Z is y. So uh, not of true is false. So not flips the Boolean values. If it's true, it becomes false, and if it's false, it will become true. And we have in and not ins. Basically, in operator, we use it when you want to check a particular value exists or not in an object. For example, I want to check whether 55 is in X or not. No, 55 is not there. What about 3 in X? Yes, we have 3 here. So that's the reason we got true. So whenever you want to check a particular value exists in an object, you can use in. Not in exactly opposite X. So if not in X, in fact, earlier we got true. So when you use not of true will become false. The same case for 55. So 55 is not in X, so we got false. So if you apply not in, it becomes not of false, it becomes true. Any questions on special operators or even assignment operators?
No, sir.
All right. So we use math library. This is the first time we are using an external library. So whenever you want to import, yeah, tell me.
So, when to use is and when to use equal to?
Your voice is breaking. Come again. When to use?
When to use is operator and when to use equal to equal to?
Okay, so equal to is going to cross-check the values. For example, x here I have taken x 1, 2, 3, 4, 5, right? Y equal to 1, 2, 3, 4, 5, right? I'm going to take z as y. Is x equal to y? Obviously, because it cross-check the values. It is not point by reference or point by value. Here, z is basically pointed to y here because we copied it. Whereas x is y, no, because x and y are not pointed to the same object, like in the case of y and z. Got it? Z and y are
Got it.
pointed to the same one. So is going to check whether it's point by reference or not. Whereas equal to cross-check the values. So now x, whether it is x equal to y or y equal to z or z equal to x, you always get true. Well, cross-check the values. But is going to check whether it's point by reference or point by value. Right? X is y, obviously it's false. What about y is z? Obviously it is true because y and z are pointed at the same object, right? What about z is x? Obviously z and x are not point reference. This is completely an isolated object, so we get false. So it's false, true, and false.
Got it.
Yeah. Okay, so libraries. So we use a lot of libraries in Python. In fact, we have a lot of free open source libraries. Um, and no, of course, if you take any programming language, Java, C++, C, we import a lot of libraries. The whole idea is not to reinvent the wheel. What does that mean? If someone already written the code, then what is the need of us to write from scratch? Let's use it. As long as it's completely been private and confined to themselves. So we can import a lot of libraries. That is, in fact, Python became a de facto, standard programming language for AI, just because it has a lot of libraries, not because it's how efficient it is. In fact, Python is not as efficient as C, C++, Java. Till research, when you look at AI research, they use C++. Python, in fact, the purpose of Python is to make a programming language available to even a beginner. It has been written, keeping a beginner in mind, rather than throwing too much on a person who started programming. It started and it came, in fact, even before Java programming language. It started in 1990s, and Java, I think, it's 1993. Python, it's 1990. Okay, so this is how we import MATLAB. So how we got this library without installation? When we install Anaconda, I told you that it comes with Python programming language. Apart from it, it comes with some basic libraries. For example, import math, import, sorry, import OS. That's another module. So import sys. That's another module. It comes with a lot of modules. It's not that it contains all the libraries that we want. So in some case, we need to install it. Let's take tip, install TensorFlow. So I think it is, so let me try. Honda activate, pip install TensorFlow. So in my system, TensorFlow has already been installed. So, okay, let's try IMB learn. Now it down, okay, it's already been installed. Install current package, IMB learn. Okay, so basically it downloaded IMB learn and installed it, right? So this is how we install library. If at all the module is not, by default comes with Anaconda. But here we don't require anything as such because it's already been installed. Import math contains a lot of mathematical functions, I mean to say methods or properties. If you press math, right, after importing the library, math.tab, tab will list out all the methods and properties that it supports. That is one of the ways to check what are all the methods and properties that a particular module supports. The other way is DAR. Any module you provide after importing it, not prior importing it. So after importing it. That is another way to get the complete list of it, but this is not recommended. So this is more recommended. So tab is math.tab. In some case, we provide alias to the library. Let's take M, right? In such case, m.tab. But here's usually we give alias when the library name is a bit longer. Instead of keep on writing, let's take TensorFlow. So if you import it, we need to keep on writing this TensorFlow dot, right? Instead of that, we can give an alias. As per documentation, the alias is TF. We can give any name we want, but it's better to follow the documentation. So that whenever you copy code somewhere else, or if you copy code of someone into your modules, it'll become quite easy rather than, giving your own name to it and get confused with other code. So here I have given that as TF, so I can use TF dot tab. So tab will list out all the modules. Let's take, if I type C, it will give me the list of methods of property that starts with C. Let's take A. So it starts with whatever the modules, methods and properties that starts with CA. We got that list, right? Okay, let's get back to the math library. Import math. math dot. Let's start with exponent, and logarithm. You might have heard E, right, in mathematics. Sorry, it is E. Let's start with E power 1. The math E is 2.718 to 818 to something. So we'll discuss that why we need why this value is so important. It's a constant. And a logarithm, let's take 6, 6. So we got 1.79. Let's discuss this logarithm and exponent in detail. You might have heard earthquake, right? And you will see something like this drum, wherein it plots the graph. It tells us like whenever a huge earthquake has happened, right? It will record it. I mean, it's not just only at times when earthquake happen. Even in regular days, it keeps on rotating and keeps on giving graph. Usually, in normal case, you're not going to see a peak, whereas in the case of an extreme case, you will see this, right? But these values are not the actual values. These are logarithmic values. So why they have taken logarithm? Let's take math, right? Log. Uh, so on the rectangle scale, it is 6.5 or maybe 5, right? So it is e to the power 5. So it's math, right? So math dot e to the power. So this is the actual value. Again, the question is still remain why we need to let's take why we need to take logarithm. So we got 403 on rectangle scale. If it is 6, it is 403. On the rectangle scale, it is 7. It is 1096. Just think that if you plot this data as it is on this drum, right? This drum is not going to be enough. We need a very large one. The problem here is the data is growing exponentially. So 5 to 6, 6 to 7, 7 to 8, there's a huge difference. The whole idea of plotting a graph is when we have too much of data, it is not possible for a human to interpret. So we come up with plot. But if the plot itself becomes too huge that it is not possible to get it in one glance, then what is the meaning of having a graph? So when the data grows exponentially, for example, if the data grows, if the data is like this, 1, 2, 3, 4, 5, and so on and so forth, right? Sorry, 10, 15, 20, 30, then we can plot a graph. What if the data is not like 1 and then 10 and then 100 and then 1000? So there is the unit distance here is 1. We can't plot 10 here. In fact, the unit distance is 1 only. So next value should be 2. But when you want to plot 10, so if the values are like 1, 10, 100, 1000, 10,000, so this data is growing exponential. And the 10 will come somewhere here. 100, this value 100 will get somewhere. Theoretically, maybe possible. Practically, it's very difficult. Again, it defies the very essence of graph. The purpose of graph is when we have huge amount of data, we can able to plot a graph, we can able to understand what is the pattern in it. But if the data itself is growing in exponential manner, it is not possible to plot a graph practically. So if you observe this data closely, it is a 10 power something. So 1 can be written as 10 power 0, 10 can be written as 10 power 1, 100 can be written as 10 square, and then 10 cube, 10 power 4, so on and so forth. Instead of taking these values as it is, we can take logarithm. So what logarithm does is we need to explain the base. What is the base here? Here it is 10. So it gives the powers. So 0, 1, 2, 3, 4, 5. So with this data, instead of taking actual values, We fix the base. Here it is 10 because the data is growing 10 to the power something. And we can take only these powers and we can able to plot the graph, right? 0, 1, 2, 3, 4, and so on and so forth. Then things will become much easier. And 0, 1, 2, 3, 4, 4, and then we can plot a graph. So the point is, if the data is growing exponentially, it is not possible to plot a graph. If we can't plot a graph, we can't get everything in one glance. If we can't get everything in one glance, we can't understand the data. That is the very purpose of graph. We need to understand the data, especially when it is huge, right? So the same case for this earthquake. It is not possible to plot a graph when the data grows exponentially. It's like 5 to 6, you can see there's a huge difference. 6 to 7, there's a huge difference. And we need an infinite term, right? So remember always that the whole idea of logarithm is to get the power. But in natural experiments, or especially scientific experiments, the base is not going to be 10 or 2 or 5. It is going to be E. What they have observed is they observed that data in natural, real world in universe, data is growing at 2.71828 to the power something. So that is how they have taken. They came up with this constraint, and whenever you apply logarithm, by default you can see that's base E. It's your choice. So let's say that if you want to fix it as 10, you can do that. For example, let's take 100. You get 2 because it's 10 to the power 2 is 100, right? Let's take 1000. 10 to the power 3 is 1000, right? So we need to get 3, somewhere near to 3, is it? So if we don't mention the base, by default it's going to be e to the power. So it says that e to the power, right? This value to the power gives around 1000. So you can see that almost 999 something. It matches with this value, right? I hope you got this point, G and logarithm. So why it's so important? We use a lot of logarithmic stuff in data. I mean to say in AI, data science. Whenever you see logarithm, just understand that there might be data that is growing exponentially. That might be the reason why they have applied logarithm. By default, the base is 2.718 something E, which is nothing but E. Okay. Any questions on exponent logarithm? So we know how to get the power. Let's say 2 to the power 3. So we use double asterisk, right? The same way we have power in math library 2. So 2 comma 3, it gives the same result, except that math.power will give it return the float value, whereas here it is integer. If you use float value anywhere here, it will also return float value. Most of the libraries try to return float value to make sure that it maintains the precision. The next one is square root. So math dot square root, for example, let's take 144. What is square root of 144? It is 12. 12 square is 144, right? The square root of 144 is 12. Let's take a simple value 4. What is square root of 4? It is 2, right? So we get 2. We can achieve that with core Python also. For example, let's take 4. It is 1 by 2. 2.2. We get the same results. Let's take 144. Previously we got 112, right? So we can achieve that using power. Instead of 2, 3, whatever, power it is 1 by 2. Or otherwise, we can simply mention 0.5. So writing 1 by 2. You get the same result of this one. This is you utilizing the additional module, that is math module, whereas this is core Python. The only difference is this will improve the readability. Whereas here, you especially those who are completely new to Python, right? They may get confused. They may have some ambiguity what this double asterisk is all about. Whereas this one, this will clearly gives us it is a math library, so mathematical function power it is power something, right? So this will improve the readability. So always make sure that whenever you write the code, it's not just you to understand the code. So others also should be in a position to understand it. Next one is fluorescence value. We had a discussion, we had an explanation on that, right? In last session, last Friday session. So it is 5.2. The floor value is going to be 5. Whereas seal value is going to be without decimal plus 1, right? So 5 0.2 we need to remove it plus 1. So 5 plus 1, 6. So we have floor and seal in math library. Example, take the same 5.2 and 5.2 here. It is without decimal floor value. So 5 without decimal plus 1, 6. So let's take 4.8 without decimal, that is 4 floor value. Without decimal plus 1, right? So without decimal plus 1, 4.8. Need to remove 0.8. So 4 plus 1, 5. So that's how we got this seal value. There's something called pi, which is another constant. It's quite frequently used in mathematics. So 3.20 something. So whenever you use this property, so whenever you see you see property, you're not going to see round brackets. This is a kind of variable. So when we declare a variable x equal to 5, is a variable, right? The same way these properties do. So whenever we have a variable that comes from class, after creating object, when we start utilizing those variables, we call it as properties. Whereas when it is inside the class, that is when we import some module and start utilizing it, basically the seal is a function written inside the class. So we create an object on top of math and we start using it. So this we call it as method instead of calling it as function. Okay, so that is the difference between method and function, property and variable. So any questions on math library? I hope this is clear. So it's a simple mathematical functions. In order to mug up this, you can start utilizing whenever you need something, just like math dot. Then you can start exploring whether that particular method, whatever the required method that you need, method that you need. So you can start exploring it. If it has, we will check it. Or else you can search in Google or you can use any LLM model. You can generate code using any LLM model, right? We have code specific model sources that generates only code that has been trying to generate code, like DeepSeek code. All right, the next one is variables. Let's take x equal to 5. So if you check type, it is integer. So Python is dynamically typed in the sense that based on the value we provide, we not to mention the data type. Based on the value we provide, it automatically assigns the data type. So for example, here let's take 5.2, automatically converted to float. Whereas string, let's take machine learning string. So it doesn't matter whether it's a single character, a word, a phrase, it's all string, is what I mean to say. So that is my intention to explain this. So either the single character, unlike Java, single character, a word or a phrase or a sentence or a document, the whole document sits in it. So it's always string data type. Okay, so as I told you that it's dynamically typed, we not to mention it. There are issues having in such manner. So Python is slowly turning into type safety also. I mean, they started introducing type safety in Python too. How do we do that? Again, there are libraries to do it. Uh, so we will discuss that later. What are those libraries? Why it is very important to make sure that data type is type safety. Data type, we need to assign data type to it. But by default, Python does not have type safety. Dynamical type in the sense based on the value it automatically changes. Data types. There are various data types that Python supports. Here we have the list of it, the main important ones. We'll see an example each. Okay, so for example, x equal to taken variable, true or false. Yeah, Python is case sensitive. So this true and this one and this one is not the same. So true need to be written as true like this. So we check type of it, this bool. Of course, the same case for false also. It's a bool. It stands for boolean. Boolean and nothing but true or false. So whenever you have true or false, we call it as boolean value. Same way we have, let's take an integer. Check data type, it is int. Int stands for integer. Whenever you have a decimal, we call it as float, right? So when a complex number, it should be in this form, x plus y j. Usually in mathematics, it will be in x plus y I. I stands for imaginary number, right? Usually in this form. It will be in this form. I stands for imaginary number. Whereas in Python, we don't use I for some reason. Whoever writes the code, they start using J. They might have used this I somewhere else for some reason. So that might be the reason why they use J. So it should be in this form. So let me give an example. 2 plus 3J. Right? If you check type, it is complex number. And this part can be removed because by default, it can be assumed it as 0 plus 3j, which is again in x plus yj form, right? So this is very well acceptable. Because don't try it in other way around. For example, don't expect that if I write 3, it will be considered as 3 plus 0j. No, that is not how it works, right? So if we take 3, it is integer. So it won't assume that it is 0j. But if you have written 3 plus 0j, it will be considered as complex number. But you need to explicitly return it. Some way or the other, it has to be in x plus yj form. And this part is very important. You have to mention it. And if you skip this x part, it assumes that it is 0 plus something, yj, whatever. String, I think we have seen a lot of examples. String, whether it's single quotes, double quotes is the same thing. So there won't be any difference. The same string, right? So list, I think we have seen it. So when you want to store multiple values, we use built-in data structures. One of the built-in data structures is list. You can say list here. We'll explore that in detail later. We have something called dictionary too. So whenever you want to store multiple values, especially when it is in the form of key value combination, use dictionaries. Let's take an example. It will be in curly brackets, by the way. It's a dictionary. The same way tuples are going to be very much similar to that of list, but it will be in round brackets. We'll see the difference between list and tuple later. For now, I'm just declaring one of the examples for each of examples for each of these data types to explain that what sort of data types that Python supports. So tuple or tuple. So pronunciation can be the tuple or tuple. Some pronounce it as tuple, some pronounce it as tuple. And the other one is set. The same, very much similar to list and tuple, but in round brackets. Don't get confused with the dictionary. Dictionary will have key val combination, right? Key val like this, dictionary. Whereas sets will have element 1, element 2, element 3, kind of. Again, the difference between list, tuple, sets, and dictionaries, will explore that in detail later. Okay, that is how you can see set. And don't bother about this immutable keyword that I have written here in round bracket. We'll see that later too. Any questions on data types? Yeah, in general, any questions related to generative AI? Those who are completely new or haven't watched the demo session, I request you to watch the demo session. There's a lot more information giving the complete overview of generative AI and what sort of content we would cover in this course. Any questions? Any discussions? We can bring it up here. I'll finish off this typecasting and then we will I will take questions. Okay. Typecasting is converting one data type to another. For example, X is 5. What is the data type of it? Obviously, it's integer. Sorry, it is integer, right? Let's take that you want to convert this into float. You can use float function. If I use X, it got converted to float. If you check type again, it's not going to be float, because when you convert to X, we need to assign it back to X. Only then it will be considered as it is really been persisted. So you can see float here. And let's take that 5.2, right? It is float, contains decimal value. So let's take that you want to convert to integer. You can do that. So of course, the original float is float, and so you got float here. Unless you assign it back, it will not return, no, it will not persist. So the change, if you want to persist, you need to assign it back. And let's take that you take a string. Let's take mission. Take string. So can you convert into some integer or float? Obviously not. It doesn't make any sense. It throws an error. Because if you're converting string to integer or float, you can use you can even if you use float, it will not, it will throw error. What if a number being wrapped in double or single quotes? We can convert it. So as long as it makes sense, it can convert it. Otherwise, converting a string to number doesn't make any sense. So it will throw error. So you need to be careful with this. The string can be, you can even write like this. We can convert into appropriate data. It's a complex. We can, it is a malformed string. Okay, so this can't be possible. Let's try round bracket. It doesn't work. So complex numbers, it has difficulty to interpret directly. But integer to float, yes. So integer float to integer, or string that has number 5.2, can we convert into some float? Yes, we can. Can we convert into integer? It throws error. So in such case, what you can do is convert to float first, and then in integer back again. So it works. Okay, all right. So I'll stop right here, and I'll start taking questions or any discussion on generative AI. S. Krishna, Nitesh, Ratnakar, and Trivikram.
Nothing from my side, Damodar. Today is my first day, so I'll
Okay.
probably ask more questions. Thank you.
I request you to watch the demo session.
Sure, sure. I need to catch
And
up on the other video as well.
yeah, other videos. So there's only one session apart from this.
Yeah,
So Thursday we had demo session, and then first class on Friday, and
yeah,
now so it's going to be on weekdays.
yeah. So I'll catch up on that first class,
Yeah,
and probably I'll have more questions. Thank you.
yeah. Any other questions from anyone else?
Nothing from my side, sir.
Uh, So watching the demo session is must. That gives an overview. Otherwise, when we keep on discussing concepts, then you lose in detail. So you need to have a good overview of what we are going to discuss, right? So kind of mind map it's going to create. Still have any questions that you feel that is not being part of the course? It has something that has to be, or any other questions related to content, right? I request you to raise questions. You can call me if you need. I think yesterday someone, Trivikram, I think, called me up. He had few questions. Same way you can have a discussion with us, get clarity on what this course is really about, what it delivers, right? And request it to be more interactive. So don't try to make it as a typical video course. Only when you start asking questions, come to know whether we're able to understand it or not. I'd always prefer a kind of Q&A session. And there's nothing wrong interrupting at any point of time. So not to wait till I complete something. All right. So if you don't have any questions, you can log off. We'll meet tomorrow at the same time. Have any questions? Please be on. Yeah, you can ask any questions.
So one quick question, just
Yeah,
that strike my mind. We are learning the concepts right now. Today we have
right.
seen sets, operators, and all these things. So we
Mm.
understood the concepts. Now, are we going to see some practical applications of how we are going to use as well going forward?
You will have projects. Let me show you an example. So ML. Let's take regression itself. Regression is one of the products that you're going to see.
Hmm.
So this template is going to be explained. This is more a generic problem in the case of ML. So this is the project. So we're going to see that in practical sense, like yes, we're going to see that. But it is not pure for Python, pure core Python. So we will add a lot of libraries. You can see that there are a lot of libraries being imported here. Not just here. There are many other libraries imported in between too, right? So
Okay.
you can see that we have imported scikit-learn libraries. So we don't write things from scratch. We utilize libraries that are more standard in AI world. And this is okay, very simple regression project. Let me show you even more complex related to generative AI. Projects. The one that I'm going to show you is generative AI specific. So we'll see, we'll have a lot of code, a lot of projects, so don't worry about it.
Mhm.
But basics is very important. Or if your choice is to directly get into projects, that is also, I mean, we have no issues. Even that approach is also fine. I'll take one project and I'll spend some 1 week or 10 days and keep on adding more and more projects. That is also fine with me, but it's your choice.
Just trying to understand. I would leave it to the team as well because we are all at different levels of learning. So just trying to
Right.
understand if that also we would see. That's what I was trying to
Yeah.
understand.
So again, it depends on the feedback that we get from learners.
Okay. Okay.
So both the approaches are fine. So learning basics and then getting into projects, or directly start getting into projects and learning it in a hard way. So consider it as in a hard way.
Okay. Okay.
The problem with the hard way approach is, there are certain basics that you may miss, but you will
Correct.
get capital exposure. Doesn't mean
Got it.
that by learning basics, we are not going to go through projects. We will definitely go through those projects.
Got it. Understood. Yeah.
Yeah. Any other
Thanks.
questions? Krishna, Nitesh, and Ratnakar.
Yeah, for me, no, sir. I'm good. Because
Okay.
I'm learning from your end, all the things.
So Ratnakar, I think, okay, so you're working in TCS, right?
Currently not, sir. I recently changed to product.
Like, what happened? So you switched from Wipro to TCS.
No, no, Wipro to product.
Okay.
Product. I just joined in the last month.
Again, you want to revise the concepts
Yeah.
along with generative AI.
Yes. Actually, most focus on the GenAI. So at the same time, I just want to revise all the things once back.
Okay. Well, just 1 month, so we'll cover the basics and then we'll get into generative.
Yeah, all good, sir. And I have a few questions. Can you add more concept in data engineering as well? Because
Uh,
when we people are when we discussing in the interviews, people are most focused on nowadays computer data sciences. They ask about that data engineering side.
that's true, but this is not data engineering course, but we
Yeah.
have 4 projects. One in GCP, another one in AWS. We have 2 projects in the Azure.
Okay.
So to address that question, so we include those projects, but our intention is to deliver generative AI, not data engineering. You need
Okay.
data engineering. If you want to learn data engineering, that will be another course altogether. So we can't fit data engineering into this. That's going to be too long then. It will add another 2 months.
Okay, sir.
So that is the problem. So we have few projects on data engineering. As I said, we have some 4 projects, but this is not a data engineering course.
Yeah.
But covering few scenarios, on data engineering will help you to handle ad hoc projects. And when it comes to unstructured data, yes, of course, as part of generative AI, you will have, let's say, PDFs or Markdown files or text files or Excel files. So we will see that we'll build pipelines for it. But semi-structured and unstructured, we have only 4 projects. All right. Any other feedback or questions?
No, sir. I'm good.
Nitesh, clear? All right. So we'll meet back tomorrow, same time. Thanks for joining.
Thank you, sir.